So this picture should look familiar. This is exactly the same table that we were working with in the last marginal revenue product video. And so just to kind of refresh your memory, we're imagining that we own a farm, that we're selling oranges, and that we're trying to decide how many workers to hire. So if we hire 0 workers, we are going to pick and then also sell, so I should put and sell here, 0 oranges. If we hire 1 worker, we will pick and sell 10 oranges. 2 workers, 30 oranges. 3 workers, 60 oranges. 4, 70. 5 workers, 75 oranges. So what made this a lot simpler in the last video is that we left price exactly the same. And so that's like a perfectly competitive market. If you remember, in a perfectly competitive market, all firms are price takers. So they just face a flat price curve. It's just constant at the price of P, which in our case was $2. So for us, that was 2 right there. Now, in this video, what we're going to do is for a not perfectly competitive market, we are going to have a firm that faces a downward sloping demand curve. So if we put quantity here and price here, you remember if like this was a monopoly or an oligopoly or a monopolistically competitive firm, any of those kinds of firms would face a downward sloping demand curve. And so with a downward sloping demand curve, what that says is if you want to sell 10 oranges right here, let's say that you can charge a price of $5. So we're going to put a price of $5 here. Now to sell 30 oranges is our next one. Let's say that you can charge a price of $4. And I'm going to run out of room really quickly here, but we can see that, I'll do 60 right here. And you can't read that, but that's a 60, believe it or not. And so let's say that you can only charge $3. So this is going to keep on going down. You'll get $3 here, we'll get $2 here, and then we'll finally get $1 here. Alright, so we are just going to completely forget about this other price column here, and we're just going to deal with the new one. So we're only going to be dealing with the not perfectly competitive market here. So we're assuming that our firm faces a downward sloping demand curve. So we're just going to erase this to kind of keep things tidy because I'm going to run out of room otherwise. And now the next thing that I want to talk about is, in the last video I had this formula down here where I said marginal revenue product is equal to marginal revenue times marginal product. And so I want to explain that a little bit more. Marginal revenue product is the change in total revenue divided by the change in an input. So a change in an input, and in our case that input is labor. So if we want to get the change in total revenue divided by the change in labor, one way to get that would be the change in total revenue divided by the change in output multiplied by the change in output, and I'm going to put that down here, the change in output divided by the change in an input. And in our case that would be labor. So I hope that some of you have caught on to this by now, but this change in total revenue divided by a change in an input, that's just marginal revenue. And then the change in output divided by a change in an input, or a change in labor, that's our marginal product. That's exactly what we calculated right here. We said we increased workers by 1, and we increased our total amount of output, the number of oranges that we picked and sold, by 10. And 10 divided by 1 is just 10, and that's how we get this right over here. So now we already have this term. We already have the marginal product. So now we just need to get the change in total revenue divided by the change in output. So I've messed myself up with notation about 3 times here, because I normally think of the change in total revenue as the marginal revenue, but we need to do it a little bit differently here, and I'll try and explain why as clearly as possible. So I'm going to explain why this needs to be the change in total revenue divided by the change in output. And I'm going to explain it as I go through this because I think that's the clearest way to do it. So first I'm just going to calculate total revenue. This is just should be a no-brainer at this point. If it's not, go back and review. But if we pick 0 oranges, no matter what the market price is, I didn't specify it, so we don't know what it is, our total revenue is going to be 0. Then 10 oranges times $5, that will be $50. 30 oranges at $4 will be $120. 60 oranges at $3 will be $180. 70 oranges at $2 will be $140. And then 75 oranges at $1 will be $75. So right now, I want to stop, pause, and kind of look at this a little bit. When we hire the first worker, we make $50. When we hire the second worker, we make $120. And when we hire the third worker, we make $180. But when we hire the fourth worker, we only make $140. And we made $180 in revenue with only 3 workers. So we're never going to hire the fourth worker, and we're never going to hire the fifth worker. So we're just going to put big X's through these 2. And I'll explain it in a different way also in a little bit. Alright, so now we are going to do the marginal revenue, the change in total revenue, divided by the change in output. So now we're going to calculate marginal revenue. So we can't calculate it for the first one because we can't have any change, obviously. So we're going to start with the second one. So our change in total revenue is going to be this difference right here. It's going to be 50 minus 0. And that's going to be divided by the change in output. Well, our change in output we have actually already calculated. It's this category right here for marginal product, but we're going to go ahead and just kind of redo it so that you see where it's coming from. So the change in output is going to be 10 minus 0. And so our marginal revenue here is going to be $5. Now for the next one, we are going to have 120 minus 50, this difference right here, divided by 30 minus 10, this difference right here, which we know is 20. So we have 30 minus 10, and so we are going to get 120 minus 50 will be 70, over, and 30 minus 10, I'm going to leave that as 70 over 20. You can reduce the fraction, but you'll see why I'm not in a second. So then the next marginal revenue is going to be 180 minus 120, 180 minus 120, over 60 minus 30, which will be, that will be plus 30. So we will have 60 here minus 30. So on the top, we are going to get 180 minus 120, which is going to be 60, divided by 60 minus 30, which is going to be 30, and 60 divided by 30 is just going to be 2. So I'm just going to write 2 right here. And this is also in dollars. Alright, so why could I already just immediately go ahead and cross out these 2 right here? Well, the reason is that I saw that their marginal revenues were going to be negative. And here's why. We have 140 minus 180 on the top, which will be negative 40. And then we're going to have 70 minus 60, which we can obviously see that that is going to be positive 10. So you have 70 minus 60. So that's going to be negative 40 over 10, which is equal to negative 4. So what that means here is for every single extra unit that you produce, you are losing $4. And remember, firms never produce when their marginal revenues are negative, because they're having to produce more, which is expensive, and they're making less money for it. So I saw that ahead of time just because I saw that 180 went down to 140, so I knew that marginal revenue was going to be negative. And so I kind of gave you the shorthand explanation and crossed them out, but here is the longer explanation. So we'll leave -4 here, but we're not going to calculate the last one just because it's a waste of time and we know that that's not going to be the best solution for this firm. Alright, so now we have marginal product and we also have marginal revenue. So we can calculate marginal revenue product, which is what we've been after this entire time. So right here we can calculate marginal revenue product, which is going to be marginal revenue times marginal product. So 10 times 5 is going to be $50. And what that is saying, one more time, is that for the first worker, and I realize I've gotten my rows kind of screwy here, but I think you can piece it together. If you can't, let me know. But what it means is that for our first worker, he increases our total revenue by 50. And so I'm going to show you a shortcut way to calculate this like I promised in 1 second, but I want to go the long way first. And so the way that we see that is that we take the marginal product, the number of additional units that he produces, which I kind of showed in the column right here or in a new column right here, and we multiply it by the increase in revenue, the change in total revenue, divided by the change in output, which is our marginal revenue, which is $5. So for the second worker, we're going to have 70 over 20 times 20. And you know what? I'm going to keep on mixing up colors here just to make this really clear. We're going to have 20 times 70 over 20, which is $70. Then we are going to have 30, the marginal product of the third worker, times $2, which is going to be $60. And so here's the shortcut way that I promised you I'd show you. If you can get to total revenue for every unit increase in workers, so you have a 1 unit increase in workers and total revenue goes up by 50. So that 50 right there is your marginal revenue product of the first worker. Now again, that's only because here we're only going up by 1. If we were going up by 2, you couldn't do this shortcut. But since we're only going up by 1 in this column over here, you can see then that when we go from the first worker to the second worker, total revenue increases by 70. And that's the exact same 70 that we have right here. So the long way is to find the marginal revenue and multiply the marginal revenue by the marginal product. The shortcut way is if you have unit increases in workers. Workers are only going up by 1. You have a column for every single increase in workers. Then you can just find the change in total revenue and divide it by 1. And so that star right there is what we are finding right here when we skip in between these two rows. So you can take the change in total revenue and divide it by the change in inputs, labors, which is just 1. So then this 180 minus 120 is 60, which is exactly what we get right here. Alright, so I hope that you see how the formula fits with the table, fits with all the computations, and how we get to marginal revenue product. And from here, from a really, really good, thorough explanation of marginal revenue product, it's very easy to see. Let's say that this firm has to pay, so this firm has to pay each worker $60, let's say. Has to pay each worker $60. So how many workers is it going to hire? So hire how many workers? So this firm is going to hire up until the marginal revenue product is equal to the wage rate. So the marginal revenue product is equal to the wage rate at 60. And there are some caveats here. It's normally marginal revenue product has to be going down. So it really, the formal definition is where falling marginal revenue product is equal to the wage rate. And here's the rationale why. That first worker can only produce $50 worth of stuff on his own. He can only pick $50 worth of oranges. But then when you add that second worker, they go ahead and produce together more than the first one could produce. There are some synergies of production there. So when you hire the second worker, he's worth $70. Then when you hire the third worker, he only can produce $60. He can only increase your total revenue by $60. So you're going to stop right there, and you're not going to hire any more workers because hiring more workers would be inefficient. So let's just say hypothetically, I worked out the numbers here so that this fourth worker, his marginal revenue product was $40. And it's obviously not. This is just hypothetical. If you had to pay him $60, it wouldn't be worth your time to pay him that. He would only increase revenue by $40, and you'd have to pay him $60. So that just makes no sense. So you hire workers up until the point where their marginal revenue product is equal to the wage rate, and the marginal revenue product is falling. And so really quickly then, let's just go find out what profit is in this situation. So you have to pay each worker $60. You hire 3 workers, and so $60 times 3 is $180. So you have costs, and I'm just going to write C here. Let's assume that there are no other costs. You have costs of $180, and you have revenue of $180. So your profit is $0. So you are doing just as well in this scenario as you could with your money anywhere else. So don't worry too much about that very, very last part, the profit part. If you understand how to calculate marginal revenue product as the product, and there I'm saying product as in multiplication, of marginal revenue times marginal product, then you're good to go. So if you understand this equation and how it plays into this table up here, I think you are all set. So it's kind of a long video, I apologize, but once you get this concept down, I think you're pretty good to go for everything else in this chapter.